Beneath your feet right now, there is a monster. Not a metaphor, not a figure of speech. A real, measurable, scientifically documented monster. It has been sleeping for 640,000 years. It has erupted before, and when it did, it nearly ended all life in North America. It is overdue, and it is waking up. Its name is Yellowstone, and today we tell the complete story of the most dangerous geological feature on the surface of the Earth. What is a supervolcano? Most people picture a volcano as a mountain, a cone-shaped peak rising above the landscape with a crater at the top. Lava flowing down the sides, smoke rising from the summit. That image is accurate for most volcanoes. But Yellowstone is not most volcanoes. Yellowstone is a supervolcano, and a supervolcano does not look like a mountain. It looks like a valley. Here is why. When a regular volcano erupts, it pushes magma up and out through a narrow vent. The eruption builds the mountain higher over time. When a supervolcano erupts, something completely different happens. The magma chamber beneath the surface is so enormous, containing so much material under such extreme pressure, that when it finally releases, it does not push upward through a single vent. It explodes outward in every direction simultaneously. The ground above the magma chamber does not build up. It collapses inward. This collapse creates a structure called a caldera, a massive sunken depression in the earth that can stretch for miles in every direction. The Yellowstone caldera is 34 miles wide and 45 miles long. It is so large that early geologists looking at it from the ground had no idea what they were looking at. It was only when aerial photography became available in the 20th century that scientists finally saw the full shape of what lay beneath Yellowstone National Park. The entire park, the geysers, the hot springs, the thermal pools, the wildlife, all of it sits inside an ancient volcanic caldera. Visitors drive through it every day without knowing they are inside the collapsed remains of one of the most violent geological events in the history of North America. The history of Yellowstone. Yellowstone has erupted 3 times in recorded geological history. Each eruption was a catastrophe on a scale that is almost impossible to comprehend. The first eruption happened approximately 2.1 million years ago. It released 600 cubic miles of material into the atmosphere. To put that in perspective, the 1980 eruption of Mount St. Helens, which was considered one of the most destructive volcanic events in American history, released less than 1 cubic mile of material. Yellowstone's first eruption was 600 times larger. The second eruption happened 1.3 million years ago. It was smaller, releasing approximately 67 cubic miles of material. Still incomprehensibly large by any human scale of reference. The third and most recent major eruption happened 640,000 years ago. It released 240 cubic miles of material. It sent ash across the entire North American continent. Ash deposits from this eruption have been found as far away as Louisiana, California, and Texas. The eruption darkened skies across the northern hemisphere. Global temperatures dropped. Ecosystems collapsed across entire continents. That was 640,000 years ago. The average interval between Yellowstone's major eruptions is approximately 600,000 to 700,000 years. We are 640,000 years past the last one. What is happening right now? Yellowstone is not dormant. It is one of the most geologically active places on the surface of the Earth. Beneath the park, a plume of superheated rock rises from deep within the Earth's mantle, a hotspot that has been fueling Yellowstone's volcanic system for millions of years. Above that plume sits the magma chamber, a vast reservoir of partially molten rock sitting between 3 and 10 miles beneath the surface. And above the magma chamber sits the ground you walk on when you visit the park. The signs of what lies beneath are everywhere. Yellowstone has more geysers than any other place on Earth. Over 500 geysers, including Old Faithful, the most famous geyser in the world, which erupts approximately every 90 minutes, shooting boiling water up to 185 feet into the air. These geysers exist because the magma below heats groundwater to extreme temperatures, forcing it upward through cracks and vents in the earth. Yellowstone has over 10,000 hydrothermal features, hot springs, mud pots, fumaroles, and thermal pools whose extraordinary colors come from the heat-loving microorganisms that live in water too hot for any other life to survive. The ground itself moves at Yellowstone. GPS measurements show the caldera floor rising and falling by inches every year as magma shifts and moves below the surface. In some periods the ground has risen by as much as 3 inches in a single year. Yellowstone experiences between 1,000 and 3,000 earthquakes every year. Most are too small to feel, but they are constant reminders that the system beneath the surface is alive and active. In 2014, a swarm of over 200 earthquakes hit Yellowstone in a single week. In 2017, a swarm of over 2,400 earthquakes occurred over 3 months, the largest earthquake swarm ever recorded at Yellowstone. The monster is not sleeping. It is breathing. What would actually happen? This is the question everyone asks. And the answer is more frightening than most people realize. Scientists divide the possible Yellowstone eruption scenarios into 3 categories. The first and most likely scenario is a hydrothermal explosion. This happens when superheated water flashes to steam so rapidly that it blows a crater in the ground. Yellowstone has had thousands of these over its history. They are violent and dangerous in their immediate vicinity, capable of throwing rocks and debris for miles. But they are localized events. They would not threaten the wider region. The second scenario is a lava flow eruption. This is what most people actually picture when they think of a volcanic eruption. Yellowstone has had dozens of these over the past 640,000 years, smaller eruptions that push lava flows across portions of the park. The most recent lava flows at Yellowstone happened approximately 70,000 years ago. A lava flow eruption would be devastating for the immediate region but would not be a global catastrophe. The third scenario is a full caldera eruption. This is the one that keeps volcanologists awake at night. If Yellowstone's magma chamber were to erupt in a full caldera event, releasing hundreds of cubic miles of material as it has done 3 times before, the consequences would cascade across the entire planet. In the first minutes, a pyroclastic flow, a superheated avalanche of gas, ash, and rock moving at hundreds of miles per hour, would sweep across everything within 40 miles of the caldera. Nothing in that zone would survive. Within hours, volcanic ash would begin falling across the entire western United States. Cities hundreds of miles from Yellowstone would be buried under feet of ash. The ash would collapse buildings under its weight. It would contaminate water supplies. It would kill crops across an entire growing season. It would shut down every airport in North America. Internal combustion engines cannot run in volcanic ash, which means vehicles stop, power plants stop, the electrical grid collapses. Within days, the ash cloud would circle the northern hemisphere. Sunlight would be blocked. Global temperatures would drop by 3 to 5 degrees Celsius. Within months. This is called a volcanic winter. It would last for years. Crops would fail across multiple growing seasons on multiple continents. The global food supply would face a crisis without precedent in modern history. Billions of people depend on agricultural systems that cannot function without sunlight and stable temperatures. Scientists estimate that a full Yellowstone caldera eruption would be the single most catastrophic event to affect human civilization since the asteroid that killed the dinosaurs. How do we know what we know? The science of monitoring Yellowstone is one of the most sophisticated geological operations in the world. The Yellowstone Volcano Observatory, a partnership between the United States Geological Survey, Yellowstone National Park, and multiple universities, operates a network of sensors across the entire region. Seismometers detect every earthquake in the region, even those measuring fractions of a point on the Richter scale. GPS stations measure ground deformation, the rising and falling of the caldera floor, with millimeter precision. Gas sensors measure the composition and volume of gases escaping from the hydrothermal system. Satellite instruments measure surface temperature changes across the entire caldera from space. All of this data flows continuously to scientists who monitor it around the clock. What they are looking for are the specific signatures that would precede a major eruption. A dramatic increase in earthquake frequency and magnitude. Rapid ground deformation, the caldera floor rising significantly faster than normal. A sudden change in the gas emissions from the hydrothermal system, particularly an increase in sulfur dioxide, which indicates fresh magma rising toward the surface. Changes in the behavior of geysers and hot springs. None of these warning signs are currently present at levels that indicate an imminent eruption. Scientists are clear on this point. The current activity at Yellowstone, while dramatic and impressive, is within the range of normal background activity. But they are equally clear on another point. If a major eruption were coming, they believe they would have months to years of warning, enough time to evacuate the surrounding region. The eruption itself would not come without warning. But the warning, when it comes, will be unmistakable. Other supervolcanoes around the world. Yellowstone is the most famous supervolcano on Earth, but it is not the only one, and some of the others are considerably more active. Campi Flegrei in Italy sits beneath the western suburbs of Naples, one of the most densely populated areas in Europe. It last erupted in 1538 and has been showing increasing signs of unrest since the 1950s. The ground beneath parts of Naples has risen by several feet in recent decades. The Italian government has detailed evacuation plans for the 500,000 people who live directly above the caldera. Taupo in New Zealand is one of the most frequently erupting supervolcanoes on Earth. Its most recent major eruption, approximately 1,800 years ago, was the largest eruption anywhere on Earth in the past 5,000 years. It shot material 33 miles into the atmosphere. The ash fall was so heavy that it turned the sky red over Rome and China, events recorded by historians who had no idea what they were seeing. Toba in Indonesia erupted approximately 74,000 years ago in what may have been the most powerful volcanic eruption in the past 2 million years. It released approximately 670 cubic miles of material. It triggered a volcanic winter that lasted years. Some researchers have proposed that the Toba eruption pushed the human population to the edge of extinction, reducing our ancestors to perhaps as few as 10,000 individuals surviving in small scattered groups. We carry the genetic evidence of that near extinction in our DNA today. What science is doing. Can we predict a supervolcanic eruption with enough accuracy to save lives? The answer today is, possibly yes, with significant uncertainty. Can we prevent one? The answer today is, no. But that may be changing. Researchers at NASA have proposed a controversial plan to prevent a Yellowstone eruption by drilling into the edges of the magma chamber and pumping cold water in, gradually cooling the system over thousands of years and releasing the pressure that drives the eruption risk. The plan is technically possible. It would require decades of drilling and billions of dollars. It would carry significant risks, including the possibility of triggering the very eruption it is designed to prevent if not executed with extraordinary precision. It has not been approved or funded, but the fact that it is being discussed at all tells you something important. For the first time in the history of our species, we are beginning to think about not just surviving geological catastrophe, but preventing it. We are beginning to think on geological timescales. We are beginning to act like a civilization that plans for threats measured not in years or decades but in hundreds of thousands of years. That is a new kind of human thinking. And Yellowstone is part of what inspired it. Closing. Beneath Yellowstone National Park, right now, as you watch this video, a magma chamber the size of a small country sits under pressure that has been building for 640,000 years. Above it, tourists photograph geysers. Children laugh at the colors of the thermal pools. Bison graze on the grass of the caldera floor. Old Faithful erupts on schedule, as it has for centuries, shooting its column of boiling water into the blue Wyoming sky. And deep below all of it, the monster breathes. We did not put it there. We cannot move it, we cannot stop it, we can only watch it, measure it, understand it as deeply as science allows. And be ready, because Yellowstone is not a threat from science fiction. It is not a Hollywood disaster movie. It is the ground beneath one of America's most beloved national parks. It is real, it is active, and one day, in 100 years or 100,000 years, it will remind the world of what it is. The only question is whether we will be ready when it does.